formula of a metal reacting with water, giving a metal hydroxide and hydrogen. They are saying that lithium reacts with water very slowly, while potassium more vigorous. And I mean, as you go down the group, the reactivity is basically increasing, right? So therefore, definitely it is going to react more and more violently. That's all, nothing much. You don't have to worry too much about this. Or one more thing, what they're trying to say is the metals. That's why it's here is this is one of the most important points, because here you have to mention why they called as alkali metals, because these metals in water they become alkali in nature, right? Alkali means what? Bases. So that is why they are becoming alkalis. That's why hence their name, alkali metals. Okay, I hope that answers your question. Moving on to the next one, reaction of hydrogen with alkali metals. This is just a simple hydride formation. Okay, your metal reacting with hydrogen forms a metallic hydride. That's all. Everything forms their own corresponding hydrides. When you look at lithium, lithium obviously forms a hydride. Any alkali metal on the other hand will have the same thing. Obviously the temperature and things like that will be different. That's all, nothing much to worry about over here. Okay, few points what you have to think about is alkali metal hydrides are ionic with high melting points. Obviously you need to know that, right, alkali metals as well as your alkaline earth metals, they form ionic compounds, hence they called as ionic solids. Your NaCl, for example, sodium chloride, Na definitely is your alkali. When you have a chloride, it is an ionic bond, right? One gets a positive charge, one gets a negative charge. Electron moves from transfer of electron from one atom to the other. That's what happens. Okay, they have very high melting point. The stability of these hydrides decrease as you go down the group. Obviously their energy is increasing, right? They become more and more unstable. That's all what you have to write over here, nothing more. One more thing you can even mention is the reducing nature of alkali increases down the group. Reducing nature means the ability to reduce something else, which means they undergo oxidation. For example, see NaH, that is your sodium hydride. In water it forms NaOH and hydrogen. So here if you notice, water gets broken up, right? Hydrogen and oxygen. Your sodium grabs the oxygen, so therefore it takes up oxygen and sodium is undergoing oxidation. Meanwhile the hydrogen is losing the oxygen, right, the OO what it has, so therefore it is getting reduced. That is why these are called as very high or a very powerful reducing agents. And the last thing is regarding the reaction of halogen on alkali metals. Okay, now any halogen, for example your chlorine, fluorine or anything of that sort, when it reacts with your metal, like for example sodium, let's consider sodium. It's very simple and easy to visualize such reactions. So sodium with chlorine, obviously in the presence of heat, it forms sodium chloride. So remember, they form chlorides or iodides or halides. So that's what you can write, their form. So when alkali metals react with halogens, they form their corresponding halides. This is the halide. So if you use fluorine instead, you get a fluoride. That's all. Okay. One more thing you have to remember here, it's this. LiF is insoluble in water because of the strong lattice energy. Strong lattice energy meaning, lattice means what? It's like a cube. Just think in your mind, this one is a lattice. It's one cube which starts. These are solids. So the whole thing is made up of each such cube like this. So to break this, okay, one mole of your lattice, to break it, that much energy corresponding is called as lattice energy. And this, when you have a very strong lattice energy, what does it mean? It is so difficult to break one cube of it. Only if you break, these individual ions will form bonds with water, right? If it is not able to break it, obviously will it form bonds? It will not form bonds. Okay, I'll repeat if you want to. Your LiF, this ability to break one cube of it, one mole of it, is called as lattice energy. If it has got a very high lattice energy, it's extremely difficult to break it. So therefore, since LiF has got a very high lattice energy, It is insoluble in water, which means hydrogen will not form bonds easily with the entire thing, hydrogen as well as oxygen. Okay. Then what else? Yes, that's about it. One very important point is about lithium. That is, it's also called as the anomalous property. It behaves differently. That is what we are trying to say over here. Okay. Lithium is obviously, there are reasons why it behaves a little differently. If you notice, in many things lithium is kind of an exception, even here, right? So lithium behaves differently. What is the reason? We're going to figure out now. Okay. First important point you can remember is lithium is a very small atom. So they're saying when all the others are big, they all behave in a particular way. When something is small, the radii also makes a big difference. So that is why the first reason you can say is it's got a small atom. It's a